Here is a simple artificial neural network. There are 3 nodes on the input layer, 5 nodes on the hidden layer, and 2 nodes on the output layer. Each node is connected to each other via connection lines. So, when a signal propagates from one node to another node, this signal will experience strengthening or weakening by a certain value, which is known as weight. In simple language, weight is a value that can determine how much influence the input will have on producing an output signal. Thus, the weight controls the strength of the signal connecting to nodes. Weight is often symbolized as W. For identification, W can be written as W11. The first subscript is the node number on the input layer. The second subscript is the node number on the output layer. After getting the weights, the input value from node 1 becomes a 1W11, or the multiplication between the input value and the weight. Each node on the hidden layer will receive signals from all nodes on the input layer. Because each signal passes through its own connection line, each connection line has a different weight value. Well, the input signal at the hidden layer node is the sum of all input nodes. For example, the incoming signal value is x1, then x1 is equal to a 1W11 plus a 2W21 plus a 3W31. Another factor that is quite important is bias. In simple language, bias is a value that can guarantee that when an input is 0, there are still active nodes there. Thus, the bias exists at the output node. In this case, the output node is node 1 on the hidden layer. Let's call it B1. The input value becomes x1 equals a 1W11 plus a 2W21 plus a 3W31 plus B1. If the number of input nodes is very large, we can write the weight multiplication in sigma notation. x1 is equal to sigma AIW I1 plus B1. This is the input value at the output node. Hopefully this tutorial can provide an overview regarding bias and weight. Don't forget to watch the next video.